This is solving radical equations. Take a minute, write down the title of this lesson, and write down this first example, which is solve the equation for the variable. We talk about solving radical equations. If you already wrote it all down, let's go talk about it. Now, in order to solve this radical equation, the first thing you want to do is isolate the radical. So once you isolate the radical, you can actually solve it by squaring both sides and so forth. So this is my radical. I want to get this alone. So I first subtract 5 from both sides, leaving me with 1.52 times the square root of x plus 1 equals a 2. And right now the radical still isn't isolated just yet because it's been multiplied by 1.52. So I'll take that 1.52 and divide both sides by it. So that way the radical would be alone. That would leave you with the square root of x plus 1 equals to whatever 2 divided by 1.52 is. So we just calculate to figure out what that is. That's roughly 1.32. So at this point, before I go any further, I know I'm going to square both sides so I can get rid of the radical here that's been square rooted. But at this point, I should always pause for a moment just to see if I'm equal to a negative number or not. Because if this was a square root equal to a negative number, you can stop and just say no solution. Because you can't square root a number and get a negative number. So if you ever get a square root equal to a negative, at this point with the radicals isolated, you should stop and just write down the answer is no solution. Now that's cube root, that's okay. Cube root can be negative, just not square roots. But this problem doesn't have that situation, so what we'll do is square both sides of the equation. So I'm taking that equation, which is the square root of x plus 1 equals to 1.32. I'm going to square the left side and square the right side. So when you square the left side, it's x plus 1. When you square the right side, it's 1.74. And your last step in order to solve this equation will be subtract 1 from both sides. Leave with x is equal to 0.74. So this is my value for x. Now, my only value for x is 0.74. Now, I don't really know if that's really the value of x until I plug it back in and check to see if it works. If it works, then it's the solution. If it doesn't work, we say it's an extraneous solution. So checking our answer, we're going to take this equation and replace the x with what we found for x. So it should be 1.52 times the square root of 0.74 plus 1 plus 5 equals a 7. So we actually do it that way. What we have is this, and I will go do the math for it and plug this to my calculator just like it says. Let's see if my left side is really 7. So I'll go ahead and add this first, and 0.74 plus 1 is 1.74. Then I'm going to multiply by, so when I plug this into the calculator, I get 2.005 plus 5 equals a 7. 2.005 plus 5 is 7.005 equals a 7. Now, it's not really equal to 7, but it's really close to 7. So like I said, it's about 7. So because we approximated our answer in all sorts of different places over here, our answer is going to be only approximately. So this is pretty close. It's off about 5,000ths of a decimal. So this is true. So this is not an extraneous solution. It's actually a real solution because it actually works in that equation. So that's how we solve those types of radical equations. First step is isolate the radical, then we square both sides. Had that been cube root, we cube both sides, and so forth. Make sure you get that as a note. I'm about to erase the screen and give you another type of radical equation. So this is example number 2. Actually take it and write it down. And the equation is square root of x subtract 2 plus square root of 3x subtract 1 equals a 7. We actually saw that the first step is still isolate the radical. So we got 2 radicals. It doesn't really matter which one you isolate. So it doesn't matter which radical you isolate, just choose one. I'm going to isolate this one because it's on the left. It doesn't really matter which one though. So I'll isolate by subtracting the square root of 3x subtract 1 from both sides. This will leave with the square root of x subtract 2 equals to 7 subtract the square root of 3x subtract 1. Now our goal is to solve for x, so we need to get this radical off of it. So now the square root symbol is isolated. I got to square both sides. And when I square this left side, it's pretty straightforward. It's x subtract 2. But when I square the right side, it's really a binomial being squared. So what we think about what that is, it's going to be 7 subtract the square root of 3x subtract 1 times itself. So basically it's going to be 7 times 7 and then 7 times the radical. So it's going to be 49 and then negative 7 times the radical. Because the radical is negative, multiply that by 7. It's really like negative 1 there. So negative 1 times 7 gives you negative 7, which is here, times the radical. And then this negative radical times 7, and this is negative radical times itself. So the negative radical times 7 is negative 7, and the radical. And the negative radical times the negative radical is a positive version of what's underneath that radical. This leaves you with 49 subtract 14 square root of 3x subtract 1 plus 3x subtract 1. So that's what it is. So on the left side, on the right side, we have 49 subtract 14 square root of 3x subtract 1 plus 3x subtract 1. There are other ways you can square binomials that can save you some work here. This always works. There's a rule for squaring binomials. And just so you know, the rule for squaring a binomial, squaring a binomial. The rule for it is basically square the first term multiply and double, then square the last. So if you ever want to square a binomial and you didn't want to go through the process of foiling it, which always works, you can follow those rules. So basically, if I gave you just any binomial, for example, if I gave you x subtract 3 quantity squared, we know that we can FOIL it by multiplying them together. But let's use the rule. We square the first, multiply and double, and square the last. So that means that the first term you're going to square it. So this can be squared, give you x squared. Second term is going to be the multiplying these two. So negative 3 times x is negative 3x. If you double negative 3x, you get negative 6x. And then square the last. This is a negative 3. When you square it, it's going to be positive 9. So if you FOIL it together, you would have gotten this. It just saves you some work if you know the rule, which is square the first, multiply and double, square the last. So it gave you a different binomial like x subtract 4. Well, think you can handle it, pause the video and tell me what it is without actually using FOIL. So pause it. Go for it. Probably got x squared. We square the first. We multiply them together. You got negative 4x, then you double it, make it a negative 8x. And then you square the last. Negative 4 squared is 16. You know there's always going to be a trinomial. Some students are going to see x squared subtract 4 and think, oh, just x squared plus 16. And they're going to forget about this middle term. Just give me the first and last terms. That's always going to be wrong. It's always going to be a trinomial. So if that's tripping you up, you should go back to FOILing it. But if you can follow those 3 steps, you always have the right answer and it will save you a little work. For example, if you were following that rule here, it would have gave you this without doing all this stuff. For example, you would have squared the first term. If you squared it, you would have gotten 49. Then you would multiply these 2 terms. 7 times its radical would be a negative 7 in the radical. And if you double it, it would be the negative 14 in the radical. And then when you square the last, you would square this negative sign and the radical, making it positive. And we know when you square a square root, you just get a number underneath the square root symbol. So you would have gotten that little expression there without having the 4. It's nice to know. So just as practice, try this one. 2 plus the square root of x subtract 1 squared. So I'm going to pause the video and let you actually tell me what that's going to be once you square it, just as a practice. So if you got 4 times the square root of x subtract 1 plus x subtract 1, you're on the right track. All right, so that's how it would have worked. You square the first, multiply and double, square the last. Now, we haven't finished this problem. We haven't finished solving for x. Let's go do that now. So I need to erase all this other stuff. So you should recognize you have like terms here and here. You can add those. You add those, this 49 and negative 1 becomes a 48. Everything else remains the same. If you notice, we have one radical in that equation now. And our goal is to isolate it. So you need to subtract the 3x, subtract the 48 to the other side to try to isolate it. Let's move it up here. So kill 2 birds with 1 stone, subtract 3x, subtract 48 from both sides now. So what we now have is a negative 2x, subtract 50, equals a negative 14 times that. You want the negative 14 to go away, so we divide both sides by negative 14. When you actually do that, you wind up having a fraction, negative 2x, subtract 50, all over negative 14. And that's equal to the square root 3x subtract 1. Now the radical is isolated. Now we've done that, we can square both sides. So when you square both sides, you wind up with this. I would square the numerator by itself, square the denominator by itself. There's other ways you could do it. I just think this is going to be the best way. For example, some people make these separate fractions, call it negative 2x over negative 14 and negative 50 over negative 14. Then squaring it that way, but it's just going to be harder. So I really square the numerator and square the denominator that way. As you see, I'm out of space. So hopefully you copy down all of this other stuff, because it's all got to go. It's got to erase everything else and actually use that space to actually finish it. So go make sure you copy it all down now. Okay, so I'm take this side of the board, cut it off, and take this piece and move it over. So when I square this numerator, I follow that rule of squaring a binomial, of squaring the first, multiplying double, and squaring the last. And I came up with this as my numerator. Squared the negative 14, I got 196. And then the 3x subtract 1 comes over. And there's lots of directions you can go from here. You could make each one of these separate fractions by dividing this by 196, dividing 200 by 196, dividing 2500 by 196. But I just generally just look at this as a fraction equals another fraction. So I would think, oh, I can just cross multiply. This is visually over 1. So if that's the case, I can simply multiply this by 196 and multiply this by 1, which doesn't change it, and get 4x squared. Oh, and this needs an x next to it. Plus 200x plus 2500 equals to whatever 196 times 3x subtract 1 is. Let's find out what it is. So this is what we wind up getting. Equals 588x subtract 196. Now if you notice, this is a quadratic equation. The way we solve quadratics is we get one side be 0, see if we can factor it. If we can't factor it, we go to quadratic formula. If we can't do that, we graph it. So here it is. We actually get one side be 0 by subtracting this one and adding 196. After you do that, you wind up having 4x squared, subtract 3, no. So subtract 388x plus 2,686 equals 0. With these huge numbers, I'm not even going to think about factoring. I'm going straight to quadratic formula. It's negative b plus or minus square root of b squared, subtract 4ac, all over 2a. So you're going to take those numbers and plug them into the quadratic formula and see what we get. So one of them is 60.3 over 8, and the other is 715.7 over 8. So my two solutions are 70.54 and 89.5. Now for the sake of time, I could actually solve this by actually using, so my two solutions are 70.54, 89.5. Now I could solve this by plugging them both in, but we're running out of time. So I'm actually using my calculator to check it. I can show you how to do it too. Basically, we said the left and the right side of the equation equals y. One's going to be y equals to this side, and one's going to be y equals to 7. So, well, truthfully, I'm out of time, but if you check your answers, you're going to find that this one's extraneous, meaning that if you plug it in, it doesn't really work, but the 7.4 works. That's all I have time. That's all time I have. Good luck tonight.